Hello everyone, I'm one of the group members from Group 54. My name is Jeremy Peter James from the Chemical Engineering Department. My other group members include Ahmad Izul from the Petroleum Engineering Department, Wan Nasrul Imran, our group leader from the Mechanical Engineering Department, Muhammad Asan Fikri, also from the ME Department, and finally, Narvin Dinesh from the Chemical Engineering Department.
A few weeks before I start the engineering team project with my team members, I have saw a lot of problems occur not only in my areas but it also happened in London, China and many more. When this problem occurred, it made me realize one thing: if we cannot reuse it well, let at least disappear it from the earth by burning it. With that, we decided to build CTS54. CTS54 is a clean trash cookstove that using the trash or waste as a burner. This is not only will help the humans, but it also help the earth to heal the environment and the conditions. To support the SDG goal and while helping the people in rural areas to cook without using electricity, the idea of this project is to provide rural areas families with an affordable, clean and safe cookstove that can be used for daily usage. The problem statement behind this is: the first one, the air pollution because of trash burning is a major factor of air pollution. The second one is people nowadays are not aware about the environmental problem that we are having. The third one, family in rural areas are not exposed to clean cookstove that can help in reducing the air pollution because of the minimum numbers of cookstove investment and innovation that use a trash as a burner. So we come out with the objective. The first one, reducing the amount of overflowing waste to promote clean and safe energy uses, and the last one is to reduce the use of natural resources in our daily life by using waste to produce energy.
I'll be talking about literature review and design concept process. For the first part, which is the literature review, we have done some research on articles related to our project. Andreas Thompson stated in 2014 that in this modern world, 40% of the world garbage is being burned in open parts, and 40 to 50% of the garbage is made up of carbon, which means that carbon dioxide is the major gas emitted by trash burning, and we know that carbon dioxide is very dangerous for our environment. He also stated that trash should be burned in appropriate manner, and if it possible, it should be burned in a way that can be useful, such as burning it to generate electricity for human use.
So, for the project planning part of our ETP, our group leader suggested that we divided the tasks amongst ourselves according to our strengths and weaknesses to ensure smooth workflow. The tasks that were distributed among us are as shown. We also did a Gantt chart. This is to ensure that everything can be done on time, and it is proven because all of the things that we had done are on point with what we had planned.
For design concept process, we started by sketching it on a piece of paper so that we can allow modification and features to be added into the design. After we came up with the full idea of the design for our product, we use AutoCAD software, which is learned by mechanical engineering students, to make the design in three-dimensional view. By doing this, we allow other people to understand our product better because AutoCAD allow the user to see the product overall in 360 view. For the animation part, we use Adobe Illustrator and Adobe After Effects, where they help us making a video for a better understanding on how the product will work. Thank you.
I will be talking about the methodology of the clean trash cookstove. A certain amount of trash will be put into the combustion chamber, but trash that is made of rubber will be excluded as it will release a very hazardous gases when it is burned. This trash will act as the fuel. After that, using a match or a stove lighter to start the combustion, the oxygen is gained by a funnel that will also act as the filtration system. The second part is the heat conduction. Heat conduction is one of the way to transfer heat. The heat generated by burning the trash will be transferred through the copper medium to the stove, mini oven and also the thermoelectric generator. And all of these three components can be used. When a component is not in use, an insulator will be put between the conductor and the component as to stop the heat transfer from continue to occur. And the last part will be the filtration system. As we all know, when burning the trash, it will release a very dangerous chemical substance and also hazardous gases that will be quite dangerous to the environment. Therefore, this stove is equipped with a HEPA filter and also an active carbon filter that can help filter the smoke.
As we know, there's an increase in waste production every day, and this waste will cause pollution. Burning this rubbish won't help either because then it will cause air pollution. Our product, the Clean Trash Cookstove, has many functions, such as heating using a stove, oven, or even charging our mobile devices. However, the main goal of this product is to be able to remove any waste products by burning them without any consequences, such as air pollution. This will not only help reduce waste pollution, but also reduce any harmful gas emissions to the surroundings. These goals are in compliances with the Sustainable Development Goals, such as affordable and clean energy, as well as responsible consumption and production. With this, we have made a survey for all the users to give us feedback on our product. And as you can see, the users strongly believe that this product can help in achieving a cleaner environment. This will also help to spread the awareness on the issue on the environment that are ongoing, and the Sustainable Development Goals, which help deals with the issue and protects the planet.
To conclude, the CTS54 is a product that is generally made to make the world a much more sustainable place by reducing the waste that is available in the world. All of the chosen materials that were used for our products were based on a Google survey that was conducted and identified to be the most cost efficient for our product. With that, I would like to say thank you for making it to the end of the video, and please enjoy the animation of our full overview of the CTS54. Thank you. Firstly, the first compartment that will be shown is the combustion chamber. This is where all the melting happens to produce the heat energy required. Next, the combustion chamber is covered in the main frame in order to ensure the fire and heat remains inside the chamber without escaping the environment. On the main frame, there is a main door whereby the user can get access to the combustion chamber to either start the fire or clean up the remain where the fire is put out. There is also a trash hole whereby additional rubbish can be put into the combustion compartment. Next up, there is a stove, an oven, and a USB charging port. These three applications will get the heat energy from the combustion compartment and perform their own tasks. These applications are covered with external cover in order to keep the heat within the walls to reduce the amount of energy released to the surrounding. Finally, on the back of the cookstove, there is a chimney that will filter the poisonous smoke produced in the combustion chamber to ensure that the smoke released to the environment is not harmful. In order to use the Clean Trash Cookstove, firstly, we need to collect some amount of rubbish and burn it in the combustion chamber. The burning process can be facilitated with a matchstick or any other thing that can make the trash burn. There is no need to worry about the amount of rubbish, as there is a threshold for the user to add more trash if the fire starts to deplete. The heat that is produced from burning will be transferred to the conductor, which is the copper conductor, via conduction. This copper conductor is used to ensure that the heat generated is not directly transmitted to the application, and also to ensure that the heat is evenly distributed among the applications. There are three applications that can be used when the heat energy is transmitted, which are the stove, the oven, and the USB charging port. To use a stove, we simply need to wait for the burning of trash to start and wait for a few minutes for the heat produced to be channeled into the conductor. After it is done, we simply need to turn off the stove with the on and off switch and start using it to cook our food. Users need to practice caution because the stove can become extremely hot due to the continuous source of heat that is produced. Users can also choose to charge their phones using the USB charging port. This is possible with the use of the thermoelectric generator. This generator utilizes the seeback effect, which will be explained in detail later. Due to utilizing the seeback effect, the cover of the USB charging station can be opened to refill the water if it gets warm. This is a cross-section of the generator to help further illustrate this process. At the top right is the USB component, which is connected to the 4 Peltier models connected in series at the bottom. As the bottom part of the Peltier models gets hotter due to the heat generated from the combustion chamber, and the top remains cold due to the cold water, there will be a temperature difference. This will then generate electricity due to the seeback effect, which is the direct energy conversion of heat into voltage potential. An aluminium plating is used to seal the components from getting in contact with water to avoid short circuits from happening. Finally, a twist lock mechanism is located at the bottom so that the users can easily remove the USB charging station to remove the water and refill it.